gonna go that in depth because this is just for the sake of introducing you to the elements of classification and machine learning. I know that some of the students here have quite a bit of exposure to machine learning. Some of you even applied or implemented a classifier by yourself. So, I mean, if that's the case, then you kind of have some perks of knowing these information beforehand. So if you can help share, help your friends, that's gonna be awesome. For those who hasn't learned or hasn't known anything about machine learning besides just hearing it from, the media and stuff, I think this is a good opportunity for you to know about it, okay? Because in the future, in daily life, you can't really avoid it, okay? All right, so a few announcements. So the first one is the retake, okay? This is, I know that a lot of people are not happy about this situation. Like, I can sense it, although I haven't seen you guys for about, is it 2 weeks? About 2 weeks, like let's say at least a week. But I know that a lot of people are not happy about it. I myself am not that happy about it. Also frustrated, equally frustrated, if not more. As I mentioned in the announcement, through consideration and discussion with not just me, okay, but with other faculties, we agreed that the way to really evaluate you on, how on your hands-on ability, this is gonna be the only way, and it's gonna take only 1 hour, plus you will have extra week to prepare for it. I'm not gonna put anything that I haven't covered in the lab into the exam, okay, that's for sure. So whatever you saw in the past portion 2, you can expect to see it again next week, okay? So now you have extra time to prepare for it, so try your best, okay? For those who can already do it, then that's cool, you don't even have to worry. But those who got not so good score, this is your second chance, so I hope that you make it count, okay? All right, any question on the retake? Tentatively, I think it's going to be at from 3:15 to 4:15. I spare 15 minutes because the library actually informed me that everyone has to leave the room by 4:30, so we can't really, we can't really end at 4:30. It's gotta have to be a little earlier, all right? So mark your calendar, put the description in that it's gonna be from 3:15 to 4:15, okay? And this time around, I won't really enforce any platform. I mean, you could use Visual Studio Code, you could use Collab, all right? As long as you do not communicate with each other, then I'm cool with that. And I'm also gonna be here to proctor the exam. So in case any incident occurs, I'll be here to, decide what to proceed or whatever, right? And you're allowed with one cheat sheet. So I think with the one cheat sheet, it means that you have to kind of cram all the information that you know, okay? Just take out those that you think is important and put that in the cheat sheet. This way, it will somehow force you to kind of compress everything into one piece of paper, double-sided. So I think, is it fair here? All right. Okay, so that's it about the retake. Second announcement is about proposal. Yeah? No. If you use Collab, then you have to use internet, but you can only open the Collab page. Yeah. Just use it for the exam only, but no searching. No. The only resource that you have is your cheat sheet. Is it a surprise? Yes. Yeah, I just mentioned that. If you use all previous labs, no. Yeah. So you open the Collab to do the exam, but not as a resource. Yeah. 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 Cheat sheet, I mean the hard copy. So like the letter size or A4 paper, both sides. They can put in whatever. You can type it up or whatever. I mean, so far we do not really cover that many, like many functions. And even the matplotlib, if you go ahead and check it out, matplotlib is also one sheet as well, double-sided. So. You've seen the exam before, so it's not gonna be, any more difficult than that. Okay. Plus, I understand that next time you have like less resources now, since one sheet compared to the internet, it's incomparable. So it's either gonna be equally difficult, like at that difficulty level, or less. All right, to be rational for everyone. All right, any more questions here? ค่ะ อะไรนะคะ คะแนนเราไป Yeah, the previous portion 2, the previous scores is like voided, not counted. But you have one more week to go. You have extra time. Plus, you've seen the exam already. So that's like quite a bit of, you have more advantage now. Okay, about proposal. So I have read, but not thoroughly, the proposal submitted from every group. Gotta say, you guys did a good job. Okay. Initially, I was planning that today I'm gonna like talk to every group regarding the proposal, but because of the things that have changed. Okay, so this will be moved to after next week. So next week is the 12th, right? So after next week, that's gonna be 19th. Am I right? Yeah. So on the 19th, everyone should be here because during the lab time, I'm gonna actually like sit down and talk to every group about the proposal that all those information, not to criticize you or anything, but more like getting more information from you, or like if I think that the scope is too much or whatever, then we can kind of tone down your scope. Or if it's too little, we may like talk what else you can do to fit your capability. That's those sort of thing. Okay, but more like getting to know more about your work. That's all. Has anyone like started the project or even completed? เสร็จแล้วเหรอ You completed? อ๋อใกล้แล้ว Oh, you're rushing for what? Any other question about announcement before I move on? No? Yes, no. Those who just came in, go ask your friend what I just said, okay? Because that's quite a bit of information. Like, that's like 14, 15 minutes-ish of information. All right, here's the outline of today. Okay, so since we'll be talking about classification and also the machine learning, I will first review, and then I will go over the concept of like model, okay? And Since I gave a reading assignment last week, who in here actually did read? Raise your hand. มีคนอ่านด้วย 1 2 3 ตรงเนี้ยค่ะ Anyone got a chance to read here? Are you aware that there is a reading assignment? คุณอย่าก้มหน้า Don't look down. Look at me. No? Okay. All right. So for those who already read, that's cool. Okay. So you will follow by skimming, like passing through your eyes. We'll go over that. Mainly that will be like the main thing that we will talk about today. Okay. And what else? I will give introduction to machine learning. All right. In terms of algorithms, but I'm not going to go in depth because we don't have enough time. I will also talk about basic types in machine learning and the concept in classification because that's the topic, that's the meat of today. And the only classifier that we will focus on today is decision tree. Although it's quite traditional, these days people don't really talk about decision tree anymore because we have transformer and more to come in the future. Have you heard of not last time, many weeks ago, there was 1 week that I showed you Lumiere. Remember Lumiere? After that, I think a week after or a few weeks after, a new thing came out named Sora. Have you heard? A few days ago. LTX. LTX Studio, so that one is for like editing the movie and stuff through prompts. Okay. So, anyways, you got the idea that so decision tree kind of became a thing that people ignored. Okay, but if say your data is not a lot and it's like a simple task, like simple classification task, there is no need to put the bees to do a simple job, okay? Plus, I talk about decision tree today because it's really clear when it comes to demonstrating the concept in classification, all right? If we talk about transformer today, I think I would lose a lot of people, yeah, because it's quite complicated, all right? All right, and then last, we will have active learning today. So active learning means that I will get everyone here involved, okay? I'll give you an activity still related to decision tree, okay? So I will demonstrate the concept, show you like some maths and stuff, and I'll let you do it by yourself, okay? So there will be like coding in the end. I'll let you work in group, okay? But if you're comfortable working by yourself, like you want to focus on understanding it by yourself first, that's cool too. All right, so here we go. What did we do so far? All right, so far, you know what are the types of data out there, right? Remember, there are structured, semi-structured, and unstructured. Okay, so that's like the very first week. And you also learn how to clean the data, how to prepare the data through different methods, okay? Mainly, we have to make sure that our data is clean, is not a garbage, and filter any information that could be a noise or we are not interested in them. After we got all these down, then it's also important to find out more information about the data, like finding the pattern through visualization, like maybe you could plot it out or find more insights from the data, okay? And then so far we have all of these down. So next we are really going to put the data in practice. We are really using it now. So the first one will be classification, okay? In the following weeks, we'll talk more about like regression, clustering, so basically other methods that could be used to find a pattern in the data and stuff. Okay, but that's the topic of the future. By the way, is the room cool enough for everyone? Do you want the AC to be more? No, it's like, all right, okay, because the room is quite spacious. Temperature is okay. If not okay, then feel free to let me know, okay? Because I don't want anyone to like faint here. All right, next. Remember this diagram. It's also showing up in the exam. นะคะ มีใครโดนหลอกบ้างไหม Anyone got fooled by this on the exam? I mean, got not full score. I mean, like got fooled by ABC. I didn't put A, B, C here. I kind of like mixed things around. Anyways, so look at our journey. See our journey? Well, we process the data, we clean, we perform data analysis. Here's where we are. And we're gonna be here for a few weeks, okay? Until maybe like 2 or 3 weeks from now. And during your project, for your project, you should be able to demonstrate to me everything here from, you know, well, you can get the data from somewhere, I don't mind that, but you will need to show me how you process the data, how you clean the data, how you perform EDA, and what methods that you use to, you know, to play with your data. And at the end, whatever results you get, whether it's good or not, are you able to communicate the results with me? If you just like throw me the results telling me that this is 99.99% correct or accuracy, then I do not accept that. Because I have eyes, I can see that, right? So if you're able to explain to me how that came about or what's your analysis and all that, then that's acceptable, right? Before we delve in any deeper, for those who are, especially those who are interested in going down the route of, you know, data-related career in CPA, this is where you are right now. Okay, so well, I'm not talking about data structure because that's like that will be more helpful for the coding and designing your code and all that. But in terms of like real data and like application of data, this is where you are right now. You're learning database to learning how to store the data, finding like the right design of your database, right? Because you have to create an ER diagram, right? And find a relationship among those tables. So you need to have like a good idea of your whole data and the database. So that's one thing that's related to storage and retrieval, okay? And data models is more like how to like really make use of that data and then clean them up, apply the methods to find out whatever insights, okay? So that's it. In the next year, in the next academic year, if you're still want to pursue in this path, then there's a big data. Is there anyone here that are interested to go for the big data class? Are you aware that we have this course? Okay. And if you're interested in like the business side of it, like how to really like turn the big data into valuable information for business purpose, then there is a business intelligence, okay? And also, since I will cover the machine learning concept today, but that's just like a really like superficial, อาจารย์นัทชา like we will have 2 instructors today to visit for active learning, so familiar face, okay, say hi. Okay, so today machine learning will be like almost like a tip of the iceberg if you compare to the entire machine learning knowledge. So if you want to know more about machine learning, I encourage you to enroll in machine learning in the 3rd year, right? And so this machine learning is still like applicable to different kinds of data, whether it's text, what else, like multimedia or just images or just videos. If you're obsessed with text, obsessed, then there's a text analytics, okay, that you could enroll. All right, so that's it for the 3rd year. And for the 4th year, well, there's a deep learning. So this one is even more intense than machine learning, all right? Because this one, I think it would involve like even more advanced concept in machine learning and also more advancement in like transformer and stuff, and also the math detail like gradient descent or like put you in different layers of neural networks and stuff like that. So if this is what you're looking for, then you could prepare for it ahead of time. Okay, and also there's a data mining class, which you can, if you're a 3rd year, you can also enroll for it too, I believe. Okay, so data mining, this one is also still about dealing with the data and stuff, but it will give you like a bigger picture of how it's used in a real world scenario. Okay, any question? Yeah. Oh. Yeah, I'm teaching this one. So if you're interested, well, next year you can enroll. If you want to avoid me, then there are, many more, 3, 5 more. มีใครอยากจะหนีอาจารย์ไหม Okay, next. Recall this. Do you recall this? Does this ring a bell? Have we seen this before? Yes, we've seen this before. This one came up in the very first lecture. Okay, in case it's just like there in the air, I'm gonna let you know that this is in our very first lecture. Okay, well, in data science, this is the cycle of how the data are being used. All right, so well, we've learned about data understanding through EDA, through doing an analysis on the data. We've learned data preparation. We're going to learn modeling, but we haven't really talked much about business understanding. So in a real data science, when you go out there and work with a company, it's not just that you have the data. Sometimes to better understand the data, you have to really talk to the stakeholders. You have to really talk to those people who collect the data, okay? So some people who collect data, they don't even know how it's gonna be used. Like they're just being told that they have to collect the data. And so it's just like metadata. So sometimes you have to like talk to them and ask them the process that they have to do to better understand what they do, okay? Because like they don't even understand why they do it, but at least they understand like the work, like maybe in the factory or the process that they are, like they were put in, right? Or you may have to talk to the CEO or CTO or everyone that's involved in the pipeline. You may have to talk to them to like understand the entire thing, and with that valuable information, it will help you better decide, especially when it comes to this part, the modeling part, okay? Or at least you know what they want, so that you could plan or come up with like a strategy accordingly, right? And then after this process, here's the evaluation. This is mainly to evaluate whether the model that you train or you came up with actually work for the business, okay? We will also talk about evaluation, but unfortunately, I don't think we have enough time today. So this is gonna be, put to the next class. right? And then at the end, after all of these are done and good to go, then you will deploy it for the company, and they will make use of it. Okay, is this clear? Is the whole cycle thing here? Sounds good? Yes. คุณอย่างเงียบสิ Sounds good? Okay. All right, first let's talk about model, okay? Because we've seen the word model for quite a bit, okay? Actually, we've seen one here, and then we've seen one here, and I think I've mentioned it time to time. So we need to know what the model really is, okay? So model is a representation of reality, okay, to serve certain purpose. So in, say, computer engineering or in machine learning or computer science, when you say model, it means one thing, okay? But if you say model to other professions like architecture, when you say model, they don't think of model as us. They would think of it as like a blueprint. For example, architecture, model is basically like smaller building that they, like a crafty work that they have to put together the materials to create a house or a building to show to the people that this is gonna be the plan that will be constructed, okay? So that's it, that's for architecture. For engineering, like say civil engineering or mechanical engineering or even electrical engineering, I believe, if you say model, that would also mean something else, like different kinds of model, okay? Another model that I found interesting is SIR model. This one, S is for susceptible, infected, and recovered. I mentioned this because a few years ago, we've gone through the COVID-19 period, like not even a period, it's like a really long time, right? So I think this model has been brought up a lot because it's trying to capture how the disease or how the virus are spreading, okay? So that's covering a certain pattern of virus, and it helps for those who are involved to come up with a plan to prevent it, or if the problem already occurs, that could come up with the plan to address it or to mitigate the problem, okay? But anyways, that's just to give you a better idea of what the model is. But for us, especially in this class, the classification model is something else, okay? It's none of these, okay? Classification is also considered a predictive model. So it's a model to predict certain scenario given input as a data, okay? So what is predictive model? So it's like, a formula, okay, to estimate unknown value of interest, okay? So this unknown value that we want to predict, at times we will refer to it as target, okay? So you can use classification model if your data is a ordinal, like ordered value, okay, or non-continuous. But if your data is like a continuous number, then we'll use a regression model instead, okay? Is that clear? We'll cover regression, I think, in about 2 weeks' time, okay? So if you're not sure what regression is, that's fine, okay? For now, that's fine. So just keep in mind that classification model is for a type of problem or data that is already in categories or already in classes, okay? Not continuous. That's like the main difference between the two. For regression, your input or what you want to predict has got to be a continuous value, like continuous numeric value. All right, is that clear? Okay. Okay, and since I've mentioned classification and regression, I think it's important to show you an even bigger picture. We've also seen this before. Does this ring a bell? first week, first lecture, okay, in case it's kind of like fading away from your memory. We've seen this before in our first class, but that time, I mean, if you don't remember it, I don't blame you, that's fine, because that was more like an overview. But at this very moment, I brought this up because I want you to see that classification is part of supervised learning. Okay, and what is supervised learning? We're going to see that in a bit. Also, regression is also part of supervised learning, all right? And, well, there is also a thing called unsupervised learning. And as you could see from the name, it's entirely like the opposite. The concept is opposite of supervised learning, okay? So that's also under, well, everything altogether are under the umbrella, like I would say umbrella of machine learning, okay? We also have like reinforcement learning. Who in here has heard of reinforcement learning? You, 1, 2, 3, 4, 5. มีใครบ้าง Can you raise your hand if at least you have heard of, okay. มีอีกไหม okay, and you're in the demo. How about the guys over here? ไหม sorry, reinforcement learning. เคย so you're kind of passing through your eyes. Okay. Okay, so the concept is, well, there's like a rewarding and a punishment kind of concept in here. So if, say, your agent, well, there's an element called agent. If agent is doing something right or something that you want it to do, you give it a reward, okay? It's like encouraging the agent to keep doing it again and again. And if not, then you give it a penalty, okay? So that's also part of machine learning, okay? Next, okay, finally, we will talk about the reading assignment. So those who haven't read, you will be put to test here. First, have you come across these terms? I think it's over 20 pages, but I gave you 1 week, so I think that's reasonable. Okay, so those topics that I assigned surely will mention classification, a little bit about regression, and also introduce you to different types of learning, the one in the previous page, okay? And mainly it talks about steps or concept of decision tree. Have you seen induction or have heard of the term induction? Induction in discrete math. Okay, so everyone heard of induction. So induction in decision tree, it is how you train, okay? Construct the tree, okay? And what else? This will be like the main portion of today, just so you know, okay? And the last, towards the end of the chapter, it mentioned about rule-based classification. So if you think about the tree or think about the binary tree that you learned last year, you can like easily implement it in like a rule-based fashion, right? Use if then, use if else, okay? If you come across the node and it splits in 2 ways or multi-way, then you can like just do if then, and then if not, then go to another route. If not, then go to another route. So it's understanding decision tree, you can like easily implement it in a rule-based style. Use if else, right? And also, I think at the very end, it talks about how to evaluate model. But as I mentioned earlier, this will be shifted to next week instead, right? Okay, we kind of have limited time today. Okay, let's quiz, like a quick quiz, okay? So I give you these scenarios. The first one is extracting the sound frequencies of a woman's voice Who in here think that this is a task of machine learning? Can you raise your hand? 1 So raise your hand. เทียอยู่ไหนคะเนี่ยอยู่ข้างหลังหมดเลยเหรอทำยังไงดีเทียจะช่วยนับได้ไหมหรือช่วยถามน้องได้ไหม I really want everyone to be involved here so หรือเอาไมค์มาขอข้างหลังกันมารับไมค์อาจารย์หน่อย ฮัลโหล Okay, do you wanna volunteer or you want me to randomly pick? ไม่เอาดีกว่าไม่ volunteer อาจารย์เลือกเอง Okay, the first question let's like I will pick the area and then you guys pick a person, okay? นะ Okay, เอาตรงนู้นแถวนู้นค่ะ that area so pick one person. My question is this scenario extraction of sound frequencies of a woman's voice is this a machine learning task or does it need classification of machine learning at all สักคนอันนี้ไม่ไปแล้ว1 อันป่ะคะโอเคเลือกเลยสบตาพี่เขาหน่อย make some eye contact so those who do not make eye contact you can pick that person คุณนั่นแหละคุณเอาเลยคุณนั่นแหละ
ใช่ครับ
อะไรนะ
ใช่ครับ
I don't think your international friends will understand.
Okay, I think it's machine learning.
It is machine learning. So what kind of techniques that is used? Is it also you said machine learning? Just machine learning. Is it a classification or like clustering or regression? Can you like be more specific?
Using frequency of voice and tone of it to classify it.
So use frequency to do classification.
Lower than frequency of women might be different from men.
Okay. But does that sound straightforward? Isn't it already straightforward? Do you really need to use machine learning for that? That's fine. I mean, you can be firm with the answer. คุณมั่นใจหน่อยใช่ก็ใช่ใช่ก็ได้อย่าหวั่นไหวสิใช่ตอบใช่เลย Yes okay so who has different opinion มีใครคิดต่างไหมคะ who think that okay this is like simple task you don't need to use machine learningยกมือก็ได้ถ้ายกมือคุณจะไม่โดนถามนั้นยกไม่โดนถามโอเคยกคือให้ตอบวะโอเคนั้นโอเคตอบเองค่ะ
so this task it can be done by doing Fourier transformation and you can just extract the frequency
okay so I guess you're saying that you do not need machine learning for this, like just segregating the data, like partition the data into groups. As simple as that.
Just feature extracting.
Okay. All right. Let's see the answer. ตื่นเต้นไหมคุณข้างหลังอะ All right. So here's the answer. So no. Okay. Well, you can try to use machine learning, but that would be kind of overkill, okay? Because the task is too simple that it's not necessary to, train the data and all that. When you have the pool of data, you can just like split based on the frequency. That's all. Yeah. Okay, next, dividing the customers of a company according to their profitability. แถวนี้นับข้างหน้าเลยเอาคนที่22อะค่ะ Like count the person who is 22nd ของคอลัมน์นี้นะคะเอาคนนั้นอะถึงไหมอะหรือเกินเหรอเอาขอ12เอาคุณไม่รอดแล้วล่ะคนที่12อะFirst, yes or no เพื่อนช่วยได้นะคะ I mean you can discuss with friends but you will be the representative I don't ว่าไงคะ answer no okay so if no then what techniques that could be used
Sorting?
Yeah. Sorting. Okay. Who has different opinion? มีใครมีความคิดต่างไหม Who think that no, you should use machine learning here? Like proudly raise your hand. มีข้างหน้า Okay, bring the mic over. มาเลย จริงเหรอนี่คนนี้ดัง
Hello. I think we can use maybe regularization graph or maybe clustering and classification model. Yeah.
Okay. So say you think that the problem here is complicated enough to use machine learning. That's cool. Let's see the results, right? So answer is no. Well, I mean, say if your data is like that large and you have like many features and say it's that complicated, then sure, I don't object to that. But for this task, say you can't just range the like based on the profitability. You could do quick partitioning. So just like the first scenario. Okay, third. Now we'll focus on the column, this second column. Okay, so the scenario is computing the total income of a supermarket. 22ได้ไหม ยังได้อยู่วะ7 8 9 10ไม่ถึง18 18เอาจากข้างหน้าได้ไหม7 8 9 10 11 12 13 14 15 16 17 เขาข้างหลังสุด so the last one on the left Sorry, but you're 18. Yes, you.
Hello.
What's the question, right? Question is computing the total income of a supermarket. Do you think this needs classification or machine learning?
I think it's not machine learning.
Okay. You think it doesn't need classification?
Maybe yes.
Oh, maybe yes.
I say yes.
So your answer is yes?
Yes.
Yeah. Okay. Who has different opinion? มีใครคิดต่างไหมว่าไม่ต้องใช้ machine learning มีใครคิดต่างเหมือน we have different opinion up front here. Okay, who has different opinion? Can you raise your hand? มีอีกไหมคะ คุณคิดต่างทั้งห้องเลยจริงๆแต่คุณไม่ยก Okay let's see the results don't take it personal okay but it's wrong so just computing the total income you can use just arithmetic okay use Excel you don't need machine learning all right next we'll go with next column from the first one I'll pick number 5 2 3 4 5คนที่5จากข้างหลังก็ได้ or from the back คนที่5 1 2 3 4 5นั่นนะคนที่5เอาถามไปแล้วเหรองั้นคนข้างหน้าคนที่5คนข้างหน้า yes you yes sorting a student database based on student names โอ้ยคุณไม่ต้องถามเพื่อนเลยตอบได้เลย
ไม่ใช่ครับไม่ใช่
ไม่ใช้ is
no
no okay so what techniques that you use instead
simple sorting
simple sorting like sorting based on what like alphabetical order you mean
alphabet
oh alpha order yeah okay so no classification needed here all right we're almost done next แถวต่อไปเอาข้างหน้าแล้วข้างหน้าเอาคนที่เอาคุณนั่นแหละคนที่2เลยตรงกลางคุณเลยค่ะคุณเลย yes you ยังไงคะ predicting the results of tossing a fair pair of dice ใช้อะไรใช้ machine learning ไหมใช้ classification ไหม
ไม่ใช่ครับ
ถ้าคุณไม่แน่ใจตอบใช่ if you're not sure say yes okay so you're sure okay so your answer is no who has different opinion you think you need machine learning here อย่าคิดยากดิ don't overcomplicate things okay like just tossing a pair of dice think of your high school years yeah okay เอาอย่าโกรธดิอย่าจริงจัง okay so let's see the answer you said no you say yes well I don't object to your idea but you who said yes but I mean you could use decision tree if you want but you can just simply use statistics okay and probability like the high school years this is also the topic the probability is also the topic that I'm not a big fan okay gotta have to admit this myself but you don't really need to go that route okay just simple stats okay next monitoring the heart rate of a patient for abnormalities ใครยังไม่โดนบ้างเนี่ยนั่นตรงนั้นเลยนั่นตรงนั้นแหละแถวนั้นตรงข้างๆ TA เลยคนนั้นเหรอโอเคค่ะโอเค yes you English ปรากฏว่าหน้านี้ทั้งหน้า no ทุกข้อนะไม่ใช่เราเล่น yes because why because there are so many no's already
no บอกเขาว่าแทงส่วน I think we can predict from the past data
you can make use of the past data
yes
for like prediction
yes prediction
okay.
from the abnormals
okay who has different opinion here ใครคิดต่างอีกแล้ววันนี้ว่าไงแต่พูดไหมพูดเนาะมา different opinion I like different opinions I want to hear your reasoning.
For me, I use signal processing with signal processing and anomaly detection instead.
Okay,
yeah.
but anomaly detection itself is classification.
Maybe you use the threshold to clustering the loss of signal rate. Yeah.
Oh, so you say
frequency.
okay. So you, if you say use clustering, then yes, it's not classification, but it's still machine learning technically. All right.
Yeah.
Cool. So answer is yes. Well, so your answer is still correct because it's under machine learning, so that's fine. Okay. Last one. Well, I would give the perks to the French students. Can you like volunteer among you guys? Okay, ไปเลยค่ะ. Nice. Predicting the future stock market price using historical data.
Now, for this topic specifically, I do believe we need to use machine learning in this case. In this case, prediction we would use to work with induction, as in working with pre-existing data to form a model on what are the fluctuations of the stock market price.
Okay.
And as such, predict with more accuracy what we can expect from
Okay.
fluctuations.
Okay. But can you pinpoint, so you say machine learning, right? That's for sure. But can you pinpoint if it's classification or regression in case you know?
That would be regression.
Nice. Okay. Correct. Because the future stock market, the value that's going to be the output is the value of the stock, which is technically a continuous value, like numerical floating point value, all right? So that right there is a regression. I think this is a good example of a regression, all right? Okay, that's it. I hope everyone is awake now after a big meal. มีใครกินเยอะไหมกลางวันนะคะ all right okay thank you everyone so here's sort of like a quick roadmap of today so I will first not even introduce now you know machine learning I will give like more clear definition of machine learning and then we will go over classification and then we'll talk about decision tree and then the activity. Hopefully I could cram everything in half an hour. Do you think I can do it? คิดว่าอาจารย์ทำได้ไหมหรือแบบสปีดเลยนะ My speed is gonna be 2x. Well, kidding. If that's Okay. Well, if I'm too fast, let me know, right? Okay, first, what is machine learning? Okay, so the keyword right here is machine and learning. Okay, so both words are actually like the key here. Okay, so machine learning is you put the machine to learn based on some sort of input. Okay, so the machine will be learned like based on your teaching. So that those teaching came from the data or input, whatever. And if it's like it has learned to a certain level, like it's good enough, just like you guys are learning, just like that. So when you are put to exam, whatever that you have learned or have seen before, then you are able to tackle that problem. Okay? If you haven't seen it before, then the chance that you could do it might be lower, stuff like that. Okay? So to put it into like a nice reading definition is machine learning is the science of getting computers to learn from the data, okay, without having to be explicitly programmed by humans, okay? So after it has learned to a certain level, then it should be able to do the task that we have trained it beforehand, right? Well, actually, this will apply to supervised learning. But for unsupervised learning, the data that you show to the machine, okay, you do not really tell it if it's right or wrong. You don't provide, they call it a label. So the machine has to like kind of figure out the pattern on its own, okay? But anyways, regardless of whether you have the label or not, the machine will be given the data, trying to find the pattern on its own, and after that's it all set, that machine, when provided with the new data, it should be able to perform the task accordingly. งงไหม if งงนะ if confused, then raise your hand. ไม่อาจารย์ว่าเมื่อกี้อาจารย์พูดเองอาจารย์ยังงงเลยเอาจริง งงไหมคะ Okay, one more time. Right? Machine learning. So machine learning is the gist of it is you make computers learn from the data. Okay, whether you could provide like a good lesson to it, which means you tell it that this is right or wrong. Like you tell it, okay, that you should jump, you should walk, and all that. Or a different technique is you let it do whatever it wants. Okay, you do not tell it that this is the wrong way, this is the right way. So whether you are telling it or don't tell it, at the end, say after the machine has seen the data to a certain level, if you provide it with the new data, it should be able to handle the task on its own. ดีขึ้นไหม? Is that better? Or any better? Anyone still confused here? ยังงงไหมคะ? If not, or if you're not sure, well, we'll see more example to test if you really understand it, okay? So here are, I don't think you can see all of these, but on the slides, even on the slides, it's kind of small. So these are all the machine learning algorithms. I don't believe that this covers the new ones, okay? But, well, just deep learning alone, it doesn't even, like cover transformer and stuff. But just to give you an idea that there are these many algorithms out there where you can like pick the one that fits your task best, okay? Although there are a lot of algorithms here, but the core concept is actually the same. If you have that solid, if you have that down, I think that will be enough for you to like kind of, based on that concept, you can enhance that further. Okay, you can like build on top of that. So it's really important that you get that you have the foundation solid. Like let's see basic types of machine learning first. Okay, so there are mainly two basic types. I mentioned it quite a bit already. So there is one that's called supervised learning. So from the name, supervised mean that there is like supervision, or there is a teacher, or there is like information that tells the machine this is right or wrong, or there is a label, okay? Let's put it that way. So that is supervised learning algorithms. And there is another one that's called unsupervised learning. So this one, this kind of learning doesn't tell machine anything, okay? It's like, let's try out this analogy. So everyone here, can you guys swim? ว่ายน้ำเป็นป่ะคะ? Everyone here swim? Okay. So supervised learning way is you go to the pool, like say you do not know how to swim. To begin with, you go to the pool, the teacher will teach you how to swim, like sort of a step by step, okay? So you have a coach to tell you what to do in order to not drown, like to not be drowned, right? And then there is like this one where you go out in the ocean and like there is a person in the back kick you into the sea, just like that, and you have to like try to do whatever to survive. นึกออกไหม? It's just like that. So whether if you do not try to swim, if you don't try to catch the air, then you're not going to survive. And whatever you have learned from that bad experience will become like the thing that you have in your knowledge base, right? But for this analogy, for this example, you know beforehand that, okay, for this stroke, you have to pull the water, like push it to the back, take it like kind of อาจารย์ต้องว่ายน้ำให้คุณดูจริงอันเนี่ย I'm not gonna demonstrate you how to swim here. But anyways, you get the idea, right? Okay, so let's see supervised learning algorithms first. So the input needs to be labeled data. And well, you have both example input and also example output. So both of them, when it comes to like training, all of them are labeled, okay? And then this will learn through those examples. And then at the end, after enough training, then it will result in the prediction model. So if your input is categorical valued, then it's classification. If it's continuous numeric value, then it's regression, okay? And to test how well the model performs, you will provide it with the unseen inputs, okay? I think now it should be clearer to you with this diagram. So with the unseen input, so this one is not even in here, like not in here, not seen, okay? No. If the model can perform well, then that's good. You have like high accuracy and you can like really use it. You can deploy it, okay? And predicted output, example of those tasks are like face detection, like object detection, okay? So you detect if there is a face or not, or object detection, you provide the image and it will like kind of circle the area and say that this is a dog and this is a cat and stuff like that, okay? Or spam detection in your email, whether it's spam or ham or not spam, okay? So that's it for supervised learning. For unsupervised learning, it's you just provide it with the input data, no label whatsoever. And then the model will be able to try to figure out the pattern on its own, and the output will be any hidden or unusual pattern. Okay, so example would be like a topic modeling, okay? Like in your corpus of documents, your model, your unsupervised learning model will be able to tell that, okay, this large document that you give it has a topic of, I don't know, say binary tree, or has a topic about like machine learning, or about introduction to data models and stuff like that, okay? So, so some of you like may have a question then that, then why do we have to, why don't we just like use all supervised, okay? Why do we have to split them up? So the answer is before in the past, I think most people are going for a supervised learning model because we have like limited data, so it's possible to train those data, okay? But these days, in the era of big data, if you think about the Wikipedia, okay, or the more data in the social network that are being generated in every second with billions of people in this world, it's impossible for you to collect all the data or train your model. Although you use supercomputer, it's impossible, and it's not practical, not efficient in any way, okay? So it would be better to use unsupervised learning. Because, I mean, if you use supervised, then you have to make sure that all your data, all the records have the label equipped, right? And how could you label all the data that are like billions, or like terabyte, or zettabyte? It's impossible. If I hire like all of you guys here to label the data for me, but each person has like gazillion of records, are you going to do it? Would you rather do something else, right? So the trend is more towards unsupervised learning, okay? And given that we have advancement in our technology and everything, now the model is more powerful. This is more practical, and they're doing it out there, in Google, in OpenAI, whatever, and many other research labs out there, okay? Okay, any questions so far? มีคำถามไหมคะอาจารย์พร่ำมาตั้งนานมีไหม All right, next. These are just more example, okay, of how classification or regression works. So let's see one regression and see one classification. Okay, so let's see classification first. So for classification, the input would be images with labeled. Like, for example, in this case, I provide to my machine or my model a bunch of pictures, like bicycles or cars or not non-cars pictures, okay? And the machine will like try to imagine this along with me. Although it doesn't click for you, let's like just try to open your mind and, you know, let this information sift through. First of all, okay? So the machine will transform the input into like a representation that's like numeric, okay? Because for machine, like computer, it doesn't really understand our human language. Although you talk to Siri, you talk to มีอะไรอีกอะมันชื่ออะไรนะอะไรนะ มันชื่ออะไรนะ That tool of Amazon, what is the name? Alexa? Yes. Or Google, like you say hi Google, and then it's like you woke it up and stuff. You thought that it understands your language, but in like the real back end of it, it's actually like trained through all this process. Okay, everything has turned into like numeric representation. Okay, after you have this representation, you use it to train the model. Okay, and then at the end, it will be able to like classify into different categories. So whether your input is like a bicycle or a car or animals and all that, okay? So the one that got the highest value right here, bicycle has a corresponding result of 0.89, okay, 0.89, which is the highest among all. So this has the highest probability. So it means that this picture has got to be bicycle. Okay, so that's like the idea. So that's it for classification. For regression, well, it's different, but the idea is sort of like still the same. Okay, so we have like, we provided with the input, which are like different features or properties, okay? Like, say this one, you have information about the house. So we know like the area, how many bedrooms, the pricing in the past, how many parking spots and all that. We have all this information, we turn it into a vector or, you know, like vector. So this is now in like a numeric representation. We use it to train the model, okay? And then at the end, it will give you the results, which is right here. It just gives you the number. So that prediction is the price is 340K for the house, like that. We'll see more in a few, if not next week, then a few weeks from now, okay? When we talk about regression. But today, this will be our thing, right? Next, this one, the same example. So just repeating what I just said. These are, say, all my input. I give it a bunch of pictures that are bicycle-like, okay? And I also give other pictures that are, you know, cars, like toys, or, well, according to this, there are more, but I don't have space, right? So based on this information, you can turn it into like property, like sort of a property, and the value for each property are basically the numbers in this vector, okay? So you use it to train the model, and then at the end, it will spit out if it's a bicycle or not. Or if it's not bicycle, then what else? It could be in this, you know, in this vector. มันก็เป็น vector เหมือนกันนะเนาะ All right. I just show you how the training data look like, which you all kind of, we've dealt with it quite a bit before midterm. So if you use the pandas and all that, you can like create a table. And the gist here is that your training data not only has like, you know, columns of attributes, there's gonna be one column that is the target or the thing that you want to predict or classify. All right, so here's like the key here. And in order to predict the target, we use all the information here for training. And each line here is a record. Okay? เงียบทั้งห้องเลย คุณซาบซึ้งในโลกธรรมเหรอ Any question? No. Okay. So I'll quickly go through the step because I want to allow enough time for the implementation of decision tree. That will be like the lab that I'll let you do it. Okay. So today will be a bit intense. Sorry. All right. So the steps in total, the core steps include feature extraction. Okay. Data splitting, model training, hyperparameter tuning, model evaluation, and then at the end, classification or prediction. Okay, so feature extraction, this is the part where you choose only the attributes or properties or the features that you think are related for the classification. Okay, so whatever features or properties that you think are not at all related to your task, you can just filter it out. Okay, you can actually filter it out beforehand once you're done with the EDA. Okay, you can just take it out, right? And for data splitting, in classification, since we need to have the portion of data to train and a portion of data that you use for test the model, that's why you have to split it into two sets. So training set and test set. Okay, that's like the core idea of this step. Then the third, after we have the training data, you can pick a classification algorithm and you train it based on the training data here, right? Next, hyperparameter tuning. Well, this is where you will adjust the parameter. If it doesn't click, that's fine, right? We can skip this part now. We'll talk more about this, if not next week, then the week after, right? Also, model evaluation, that will be the future as well, right? And then here's the last step. This is where, say you have like the model ready, you have training data ready, you have test data ready. We can, and you train and test and everything. This is where you will do the deployment and really use it, you know, like put it to real use. เดี๋ยวคุณอดทนหน่อยนะเดี๋ยวไปพักทีเดียวตอนแลบเลยนะเอาให้จบก่อนนะคะ All right, here's just the training part. Also put in a diagram here. So the training part, I grade out all this. So during the training, we're technically doing all of these, you know, the whole thing here. So we have input, we extract only or pick only the features that are related, and we have the features ready. We put it to use in our machine learning algorithm. All right, and the tuning and evaluation is also like sort of done here, right? And the prediction is where when we already have the model ready, so we do a prediction. All right. Any question up to this point? I think we're gonna go into decision tree now, like right about now. พร้อมไหม Are you ready? Am I losing you? คุณยังอยู่อาจารย์ไหมอยู่เนอะ Okay. Decision tree. So we sort of saw this. You've seen tree before. Tree here. I mean trees of computer. You've seen this last year. I remember that. Okay. So well, now it's a matter of like really use the decision tree to do a classification for your data. Okay, this one is just like illustration, which doesn't really mean much. So you do not have this in your slide because I'm hiding it. Okay, but this is an example of how decision tree would look like. Okay, for example, this one, the very root node is first checking the outlook of the weather. Okay, so whether the weather that day is like sunny or overcast or raining. Okay, and whatever branch that you go through, it will do more testing, like checking. Okay, so say if it's sunny, then you check the humidity, whether it's high or normal. Okay, so if it is high, then the result is no. No here could mean that there is a hail that day, for example. So there is no hail if the condition looking like this. If it's sunny and high humidity, then the probability of having the hail is like no, like just no. Okay, but if it's normal, then yes, there's gonna be a hail that day. Okay, so or if it's raining that day and also the wind is strong, ตัวอย่างอาจารย์ไม่ดีเลย if the wind is strong, then no hail. But if the wind is weak, then there's gonna be a hail. Okay, just a quick example. Do you know what hail is? ลูกเห็บ โอเคอาจารย์มั่วขึ้นมานะคะมันน่าจะไม่ตรงแหละ Alright, so key elements of decision tree is first tree induction. Okay, so as I said earlier, like once, if you caught it, tree induction is the process of training. Alright, and what you have to be concerned when it comes to creating or constructing a decision tree is how do you determine which feature should be the best split. Okay, because like say in your data you have like outlook, you have humidity, you have wind. How do you know if you should split based on outlook, or you should split based on humidity, or why isn't humidity should go here? Why is it right here? Why the wind is not here, and stuff like that. Okay, so all of these has to be taken care of. All right, so we have to take into account the best split, like which feature should be the one that will give you the best split. You will see node impurity. That's like a key concept that you will see in a bit. And also entropy. Has anyone like heard of entropy here? เคยได้ยินไหม Entropy. You have heard. Okay. Oh, you've heard that in chemistry. This is, I think, same concept, but no bonding, nothing about chemistry involved, right? And we have information gain. Okay, so all of these will be used to determine what node should be the best split and stuff like that. Okay, let's first determine the best split. Okay, well, I have 3 examples here, and they're all ordinal attributes, meaning that they're all, you know, like not continuous value. Okay, so which one do you think should be the way to go? Should I split like entirely, like family cars, sports cars, luxury cars, like split it entirely, like for different type, or should I combine sports and luxury together versus family, or should I combine family and luxury together and sports? What do you think? Okay, so one say that this should be the way to go. Who thought that a clear distinction like this is better? มีใครว่าแบบแบ่งแยกไปเลยดีกว่า I shouldn't speak Thai, sorry. Who think this is like a better way to go? Can you like, boop? Okay, I saw a few hands. Who think this is a way to go? Family and luxury together versus sports. Yeah, I mean, some shaking. No, the answer is I don't know either. Okay, so well, personally, I would go for this one, but you don't know if it's really the best. The way for you to know that this is really the right choice is you really have to quantify it. Okay. Or yeah, you have to quantify it. Okay, another example. Say if my attribute is a continuous value, should I split it like in a binary approach, like binary fashion like this, or should I split it like more, fine grain? Yeah, so someone say this. Who thinks that, who prefer the binary approach? Oh, okay, one. Okay, again. Yeah. Mm-hmm. Okay, so it also depends on the people that are in charge, you mean? Okay. All right, yeah. And the answer is just similar to what I said earlier. We need to quantify it, okay? And the last one, can you see it? The last one, say before split, I have like 2 classes, okay? I say class 0 and class 1. And so both classes have total of 10 records, both of them. Which one do you think is having a best split here? อันไหนคุณว่าดีสุด? I shouldn't speak Thai, sorry. This one? So the student ID, you basically you have these many branches according to number of students. Each student has their own branch. And then each branch will have like output as like a class, whether class 0 is 1 or class 1 is 0. Say if I have, in this class we have 92 students. So I'm gonna have 92 branches. Do you think that's practical? Probably not. Okay, so I would discourage to go down this route. How about here? Own car. Just to check if like the person with has a car or not. So say like if the person has a car, then 6 of them are in class 0. Like 4 of them are class 1. Are you with me? Some is in a shocking state. คุณช็อกอะไร? Mm-hmm. Class is like for example, class 1, class 0 is student. Okay, เราตัดอันนี้ไปนะ I'm gonna cut this out entirely, right? So say class 0 means student. Student is, what is student in French? Étudiant. Yes. I know some. Okay, and class 1 isอะไรดีอะ? Class 1 is a teacher. Okay, so if a person, you don't know yet that that person is a student or a teacher, but that person owns a car, okay, or not own a car. So you use this to determine if the person is a student or a teacher. Uh-huh. Mm-hmm. Can you actually tell based on just doing yes and no? So like if the person owns a car. 6 of them are student, 4 of them are teacher. And over here, 4 of them are students, 6 of them are teachers. Is that like clear enough for you to do a judgment? You think so? Okay. But let's say if I change the number here, okay. If owns a car, then class 1 is 9. Class 0 is 0. Okay, but for the no path, class 0 is gonna be all 10, and over here is 1. Is this better? If if someone comes in and tell you that I have a car, will you be able to tell right away with this model that you must be a teacher? Ao mai. Student and teacher, okay? You remember? This student, this is a teacher, okay? If I change the number here, I will go with extreme example. So say both are 5, 5, 5. All of them are 5. So someone comes in, you ask, okay, the guy owns a car. Can you tell that that person is a teacher or student here? When all the values here are equal, right? You can't determine because it's like equal probability here, right? But if I change the value here, if this is like 10 for class 1 and class 0 is 0, and the other way around, this will be 10 and this is 0. If someone comes in, tell you that I don't have a car, can you tell that that person is a student? Yeah, that's like the idea of node impurity. Okay, so if it's hard for you to tell, if it's like all mixed up, then it means that this node right here is not pure, or the information here is not homogeneous. Okay, let's skip to the next page. Okay, node impurity. So that's exactly the example that I just showed you. This one is not that clear. Also, this one is definitely the worst one. Okay, but this one is so pure. Like, it's so clear cut that you can like just use this information and yes and no, and you'll be able to tell the class that the input belongs to. All right. So ideally, the group should be as pure as possible, just like this. Pure means like a clear cut like this. This one all belongs to class 0. This one all belongs to class 1, right? But in real data, it's gonna be hard to have a pattern like this, right? So, อาจารย์จะทำได้ไหมเนี่ย So node impurity here, for you to determine the purity, we use the method called entropy. Okay, so entropy is a measure of disorder, right? So basically, disorder is to check how mixed your attribute is. Okay, if like both classes of that attribute is like all like equal probability, that's 5, 50, 50%, then it is so impure. That's gonna be, the result will be like 50%, okay? And here's the formula, okay? You don't have to remember it because I have it in the later slides as well, but the key here is the higher the entropy value is, then it indicates that the node, like that very node, is not discouraged, is discouraged to be used for your decision tree, okay? Or it could be used later, but not like at the very beginning, okay? But the node with low entropy means that it could give you like a clear-cut answer, and it's encouraged to use, okay? I mean, just the idea, like if you're okay with this, then we can move on. เข้าใจไหมคะ? Is everyone on the same page? Okay. If not, when you see example later, I think it would be helpful. All right, so example right here. Entropy. I'm gonna compute, entropy of a node. Okay, so my node could be split, like the results could be either C1 or class 1 or C2 or class 2. So you can think of C1 as like yes, and C2 is no, just like that. Okay, so say if we okay, if the amount of class 1 is 0 and amount of class 2 is 6, by using this formula, you can calculate the probability, okay? Probability of C1 giving the node T, okay? Over here, I give, 0 and 6, so you could just do 0 over 6. This is like all 0, no chance at all, because like no data, okay? But for class 2, because everything is falling into class 2, that's why it's 1. So when you compute the entropy, you could see that the value is 0, which means what? Let's go back here. Low entropy is encouraged because it means that that node is very homogeneous, meaning that if you go down that node and go through one path, it's like all clear cut. Okay? So, okay. So, you can't go lower than this. If you go lower, it's gonna be negative, which is impossible. Okay, so this node is like a really good node. Okay, you actually should use it. But let's see other examples. This one is like 0.92. So that's not good compared to this case. All right? งงไหม? Are you with me? Still with me? Okay. Maybe this page is not that clear. Let's see the next page. Okay. I'm pointing to this one that we should go with this option. Or, yeah, we should go with this node. Okay. So, so this is the case where like everything is a no. Okay, so your attribute, okay, all of them are like all no. It's just like this. But if like one is a yes, then if you compare to this case, when you calculate and get 0.65, this is how it looks like. So still the majority is still no, so that's not too bad, right? But in case that is like 2 and 4, and you get entropy of 0.92, if you look at the data right here, although the majority is no, but there's still like 2 that is a yes, so it's like not that guaranteed. มันเยอะเกินไปแล้วใช่ไหม สำหรับวันนี้ ใกล้ละ almost done. Okay, but this information alone is not enough, okay? Because we're just talking about one node, okay? But when we talk about decision tree, it has multiple nodes, all right? So entropy is just like part of the whole story. The whole story is information gain. Okay, so you use information about entropy to finally compute the information gain. So information gain will measure the change in entropy after you further split the tree. Okay, and here's a formula. So the gist of this page is if you get like high gain, okay, the high gain is encouraged, meaning that like you gain more information out of that choice of split, okay? But if you have like low gain, meaning that you don't really gain much, that is discouraged. That node is not encouraged anymore, okay? I have one example, and after we're done with this, hopefully in 5 minutes, then I'm gonna let you actually implement this by yourself, in groups if you want to, okay? So I have this data, can you see it? Sort of, okay? So this is information about people, okay? So whether that person is a student or not, and the income and the age, But at the end, all you want to predict or you want to classify is you want to know if the person with these properties are going to buy a computer or not. All right? So with all the formulas that we have, here will be the steps that we will walk through. Okay, so first, we will compute the entropy of the entire data based on our target. Okay, so this. And then for each attribute, we need to know which node that we want to split upon to create the tree. So we will compute entropy of different attributes, so all attributes, okay? And then at the end, we will find information gain based on the entropy value of each attribute and then make a selection at the end. Okay, so the one that gives the highest gain, that is the one that we will go for. That's like the idea. So at the end, you want to gain the most. Yeah, that's all. All right, so first, we will compute the entropy of our entire data, okay, or our target. So you can follow this, like go through the slides and walk through this with me, okay? We'll use this formula and our data, our target, we have 9 yeses and we have 5 no's, okay? So a probability for each is going to be these 2 values, all right? So just like that, with this information, you can compute the entropy of our target. Just plug this value in and we get 0.94, right? So next we will start doing the splitting, okay? We will first split based on age, okay? Okay, so still the same formula as entropy. So now it's entropy of age, okay? And I plug in my variables. So we will compute entropy based on partition I. So you need to like look at the age first of all. How many values are like, how many categories are there in age? We have less than or equal to 30, right? And we also have 31 to 40, right? And then we have more than 40. What else do we have? Yes, we only have 3 groups. Or I created this image for you. We have 3 routes to go based on each attribute, okay? And let's count how many less than or equal to 30 that are yes, and how many that are no. So you have to use both attributes now. So less than or equal to 30 are this, right? Boop, boop, boop. How many that are yes? We have 1 yes, 2 yes. So 2 yeses and 3 no's, like that, okay? And for 31 to 40, you do the same thing. I've done that for you, right? Okay, so 4 yeses and this, oh no, 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 no. 0 no, okay? And this one, 3 yeses and 2 no, okay? Anyways, I will turn this into a table, okay? So remember this, it's gonna become a table now. Same information, all right? So next, I'm going to use this formula now to compute entropy, okay, based on age, okay? So I use the same formula, compute the probability if like the age, I will do this one first. Okay, but you have to do all 3. This is kind of tedious, but let's focus on this one first. So if the age is less than or equal to 30 and the decision to buy computer is a yes, then the probability is 2 over 5 because there are only 2 over all of them that are 5, right? This is like the entire thing, 5. And for those that are no, are 3 over 5, like 3 right here. Everyone follows? Okay. So when you compute the entropy, plug in these values to the formula. Same formula, you get 0.971. Right? Let's keep going. Boop. Okay, but over here, I still like kind of, hide this thingy. This thingy is used, I shouldn't be saying thingy, but it's a thingy. This ratio is like the weighted information. You apply the weight, okay? Or the weighted ratio, which in this case is basically total number of this case over the entire records, okay? So number of this case, we have 5, right? And number of all records here are 14 if you actually like count it, right? So we will apply 5 over 14 and then times that with the results that we got earlier. So we get 0.347, all right? ไปต่อนะ Next, okay, magic. I have computed everything else for you. So far, this is like what I showed you. And this you can figure out yourself. You can check if I calculated this correctly. Okay, but magically at the end, this is the final result for the attribute age. Okay, so far we got this portion, like the whole thing here. This is 0.694. Okay, next. So now we can find the information gain value. Okay, so if we split based on the attribute age, the entropy of the entire 3 that we got earlier, 0.940, minus the entropy based on splitting age attribute, we gain 0.246. Yes, this is just like one attribute only. To construct the tree, you need to find these value based on income, based on student, based on credit rating, so that you can determine which one gives you the best gain or the highest gain, and you use that one as the node. And that's gonna be your job now. I think the notebook is already available if you check out on LEB2. Okay, so you can download that. Yeah. So now time for you to write the code. What I provided to you is the data and the formula and everything that I said earlier. Now is your job to really get your hands dirty. ทำSee if you can like at least finish this one in class today. In class means at 4 p.m. You have 45 minutes. I'm not asking for too much. I'm asking for only one gain based on income. Do you want to work individually or as a group? Actually, I want everyone to work on this. Like, you really work on this individually, but you can discuss. Okay, let's do that. I know sorry CSV file right sorry I'm gonna give it to you nowค่ะก็ทำด้วยกันได้ค่ะเดี๋ยวนะจะทำอะไรก่อนนะลืมแป๊บนึงsorry แป๊บนึงนะคะใช่ค่ะให้หาเกณฑ์ของ3 คอลัมน์นี้ใช่แต่ให้เขียนโค้ดไม่ต้องทำด้วยมือเขียนโค้ดไปเลย the data right the data is going to be available in 10 9 8โอ้ยอินเทอร์เน็ตมันช้ารอแป๊บนึงOkay, it should be available now. Okay, it's ready now. Refresh. ไม่มีในสไลด์ ก็นี่ไงดูอันนี้ เป็นวิธีไม่ทำก่อน Hello. Well, you in your notebook, you gotta have to show me how you actually do it based on how I taught you. Okay, not just calling the library and give me the answer. Okay, that's way too easy way out. You can do that to verify your answer, but in terms of the work that I would check based on what I taught. Okay. Hi guys. I think there is a typo here. So over here, take a look. This number here, supposed to be, well, on the slides, it's wrong. It's supposed to be 0.971, okay? Yeah, but I will make a correction and then I will upload the slides, okay? But now we are on the same page that this is supposed to be 0.971. ตัวเลขมันผิด เดี๋ยวขอแก้ก่อน ค่ะ แต่หน้าที่แล้วมันไม่ผิดนะ มันผิดหน้านี้เฉยๆ แป๊บเปลี่ยนแล้ว โอเคแก้แล้ว alright okay so let me say a few more things so in this class finish at least the first one alright so this is the bare minimum finish this one where based on everything that I talked about in the previous slides do it through coding okay you can like do it on a paper too but then transfer that into Colab right and show the work and show the results if you split based on attribute income okay so this is the bare minimum for the class today until at 4 p.m. and this will be your homework but that's not it yet the homework is also including next page which you have okay so I give you the entire decision tree algorithm okay since you have studied algorithm I think you can understand this this algorithm just fine okay you have calculated information gain and follow through all this construct the decision tree all right and put that in the same Colab so at the end your results should be able to like tell me which is the root node and then splits into which attribute and then so and so งงไหม your homework is to construct the decision tree that's allเสร็จแล้ว the at least by today, you need to submit the information gain based on income. What time do you think you can finish this? เสร็จไหม6 p.m. ไม่เสร็จหรอ จริง เที่ยงคืนเสร็จไหม so ไม่เที่ยงคืน1 นาทีก่อนเที่ยงคืน23:59อ่ะถ้ามันอาจารย์จำเลขไม่ได้ไงถ้ามันใช่ก็ถูกเลยเก่งมากถูกไหมถูกคุณก็เนี่ยได้อันแรกคุณก็สเต็ปเดิมค่ะโอเคถ่ายรูปใช่ Okay, feel free to take a photo. So this one, do you want the due date to be the 11th or the 10th? Considering that the retake will be on the 12th. คุณอยากให้ส่งวันที่10หรือ11เนี่ยอันเนี้ยมันจะนานไปไหม So who want the 10th ไหนยกมือหน่อยใครอยากให้ส่งวันที่10คือนี่อยากจะให้ส่งวันที่11หมดเลยเหรอโอเค Okay, who's done with the first one? Income. Okay. You're good to go. The rest is gonna be homework. Who else? ไหนยกมือหน่อยสิใครเสร็จ Who else has finished the first one? ขอดูไม่มีใครเสร็จเลยเหรอ จริงดิ Hello. For clarification, for those who has a question about decision tree here, I provided you this algorithm in the slides, emphasized in the slides, okay? So if you're gonna just like call the library from scikit, learn whatever, that doesn't count, okay? Because that doesn't count. Okay, here is the algorithm that I talked about. All right, so it's if else mainly. Okay, but you have what's the year that you studied algorithm เรียนอัลกอร์เทอมไหนคะเนี่ยเทอมที่แล้วปะเรียนวิชาอัลกอริทึม Last semester you studied algorithm, so you shouldn't have, I mean, I expect you to know how to interpret this, okay? To be able to interpret this just fine. All right, okay, by the way, we have a constraint to leave this room before 4:30. We can only use this room up to 4:30 p.m. So, hello. If you're done with the first assignment, just upload it on Alibi too, okay? Make sure to do so by the end of today before midnight, okay? And the rest is gonna be homework. And next week, we will have exam. We'll have lecture first. Next time, I promise to not overload you with too much information, because that will that will be a trouble in case like you have too much information. All right, we will have like lecture first, and then we will have a retake exam at 3:15. All right, any question? มีใครมีคำถามไหมคะ Okay, if not, then prepare to leave the room soon, okay? And thank you.